네, 안녕하십니까. 데이터브릭스 코리아 솔루션 아키텍트 팀의 장경훈이라고 합니다. 반갑습니다. 오늘 웨비나에 참석해 주셔서 감사드립니다. 여러분이 잘 아시는 것처럼 데이터브릭스는 4년 전부터 레이크하우스라고 하는 새로운 개념을 최초로 시장에 소개한 이후로 스파크나 델타, ML플로우 같은 오픈소스 소프트웨어를 중심으로 클라우드 기반의 데이터 분석 시장을 주도해 오고 있습니다. 저희는 데이터와 AI라고 하는 이 두 가지 영역을 하나의 플랫폼에서 효과적으로 다룰 수 있도록 했고요. 이것을 통해서 고객분들이 새로운 가치를 창출할 수 있도록 다양한 기술 혁신들을 지속해 오고 있습니다. 특히 작년 초부터 거대 언어 모델을 시작으로 해서 AI 트렌드가 전 IT 업계를 뒤흔들고 있죠. 데이터브릭스는 이러한 시장의 변화를 주도하고 AI를 기반으로 하는 새로운 혁신을 지속하게 하기 위해서 모자이크 ML이라고 하는 AI 전문 기업을 인수했고요. 제품과 서비스 통합을 지속적으로 해오고 있습니다. 오늘은 AI 시대의 데이터 엔지니어링이라고 하는 주제로 최근에 더욱 중요해진 기업 내의 데이터 요구에 효과적으로 대응할 수 있는 방법들에 대해서 알아보는 시간을 가지려고 합니다. 오늘 공유드리는 이 웨비나는 최근에 저희 본사에서 진행했던 웨비나인데요. 저희가 빠르게 한글 자막을 입혀서 국내 고객분들께 다시 공유드리는 형태로 세미나를 진행하게 되었습니다. 아무쪼록 유익한 시간이 되시길 바랍니다. 감사합니다.
It's time. The potential of data and AI is too big. And the problems we're solving are too important for it to be so hard. It's time to set your data up for success. Time to let it drive. Because data is all grown up now, but we still haven't taken the training wheels off. It's time to be open, to unlock, unlimit, and unleash data. It's time to work together as data teams, as a data community. Innovation doesn't happen in isolation, because when we're united, we do what teams do best. Above all else, it's time to simplify. One place for all your data. One foundation for every workload, from BI to AI. One platform that runs where you run. One architecture that puts an end to the trade-offs and brings it all together. One lakehouse. Databricks helps data teams innovate faster on the world's first and only lakehouse in the cloud. Open, simple, collaborative. Now you can have it all your data, all your analytics and AI, all your data teams. One platform for today and in the future. It's time for Databricks.
Welcome everyone. We're so glad that you've joined us today for this virtual event, Data Engineering in the Age of AI. My name is Matt Jones from the Databricks product marketing team, and I'm going to be leading you through today's event. We've got a really great slate of speakers and topics lined up for today, and we're going to be talking about data engineering primarily, but in the context of this generational AI disruption you're likely all experiencing. First, our distinguished engineer, Michael Armbrust, will give an overview of the landscape, including what's happening with generative AI today, how organizations are architecting for AI, and then some battle-tested data engineering best practices. Next, we'll double-click into data engineering for AI on the Lakehouse and hear from T-Mobile on how they've built out a highly successful data-centric AI platform. And with that, I'd like to introduce our first speaker today, Databricks distinguished engineer, Michael Armbrust. Michael is the original creator of Spark SQL, Spark Structured Streaming, and Delta, and he currently leads the Delta Live Tables team here at Databricks. Michael's going to get us started with our topic of data engineering in the age of AI. Enjoy.
Thanks, Matt. I'm really excited to be here today to talk about data engineering in the age of AI. But first of all, why are we so excited about this? Here's a quote from Dr. Carbon, an associate professor at MIT, who says, "I can't think of anything that's been more powerful since the desktop computer." And when you hear things like this, it's kind of natural to be a skeptic. I'll admit, even I was skeptical. But the real moment of realization for me was when I started using generative AI in my everyday life. I'm a pretty decent programmer, but I don't know JavaScript, and I've been teaching myself in my spare time. And at one point, I had a bug in my program, and I couldn't for the life of me figure it out. I just took 3 pages of JavaScript, pasted it into ChatGPT, and said, "Where is the bug?" And it immediately identified exactly what it was and explained to me why it was broken and how to fix it. And that was really a light bulb moment for me. This is different. This is not like the AI we were using before. This is something that's going to change the world. And I'm not the only one who thinks this. Generative AI is going to change the future of work. 78% of executives surveyed saw generative AI will have a huge impact on driving innovation. And one of the big places we think that this is going to happen is in productivity. Studies have shown that people complete tasks up to 56% faster when they're using software-based AI assistants. And this is going to have a huge impact on revenue. We think there's a multi-billion-dollar opportunity in just the next couple of years around generative AI assistants. So looking back, we think that when people talk about the year 2023, this is going to be the beginning of the age of AI. And if you look around, more than 70% of organizations are already in exploration mode, trying to understand how generative AI is going to impact their business. And 20% are already in production. And we've seen this kind of across the entire ML space. Companies are putting more than 400% more ML models into production this year than last year. And we think that by 2026, over 80% of enterprises will have used generative AI APIs or models in some type of production environment. And this is up from less than 5% at the beginning of this year. However, things aren't all that rosy because many executives know that data problems are going to be the things that sink these efforts. And the reason for that is it doesn't matter how smart your model is. It can't overcome bad data. If you put bad data in, you're going to get bad data out. And the problem isn't going to get simpler. Today, most models are trained on real data that is obtained from direct measurements or created by humans. And this is great because it's often correct. It's about the real world, but it's incredibly expensive. So you're constrained by the cost and logistics and privacy problems of using data generated by humans. And so we think in the future, training models is going to become even more complicated because you're going to have to use artificially generated data that comes from simple rules or statistical modeling. And this is what's going to really cause an explosion of data that needs to be used as the input. And data engineers are the ones who are going to have to wrangle this massive collection of data and feed it into the models. And in order to think about the jobs of data engineers, we've come up with what we like to call the 5 C's. Data needs to be correct, it needs to be current, it needs to be complete, it needs to be controlled, and it needs to be cost effective. And sadly today, this is often far from reality. And so this is why Databricks has always had the mission to democratize data and AI, to enable everyone in your business to use it effectively. And one of the big challenges here is typically the worlds of data and AI have been completely separate. If you think about the kind of traditional relational data warehouse, you were always thinking about structured data. It's often correct because it's highly curated and it's easy to get answers out of it, but it can be really expensive. And because it's so expensive, it's usually not all of your data. And then there's the world where Spark was born, unstructured data. This is the data lake. It's just a file system and everything is put out there. So it's complete, but it can be very difficult to get correct answers out of it because it's incredibly messy. And again, if you don't know how to get correct answers out of it, it becomes a huge drain on the cost of your project. And this is why we created the Lakehouse, which unifies these two concepts into one unified whole. And inside of Databricks, the first Lakehouse platform, we have all of the pieces that you need, from orchestration in Databricks workflows to traditional data warehousing inside of Databricks SQL, to Lakehouse AI, which allows you to do data science and ML, and then finally a new product called Delta Live Tables, which makes it possible for everyone to do ETL and streaming. Now, the data lakehouse is a relatively new concept. We actually pioneered this idea back in 2020, but it has taken the world by storm. Today, more than 74% of global executives have already adopted the lakehouse inside of their enterprise. And the reason for this is the lakehouse is the best platform for doing data engineering. Let me walk through some of the reasons why. Starting with Delta Live Tables, this simplifies both batch and streaming data ingestion into one simple platform. Rather than having to learn Scala and Spark and learn how to write effective Spark programs that are performant, Delta Live Tables takes a declarative approach. All you need to do is write simple SQL queries that say what tables should exist and what data should be in them. More advanced users can use Python data frames. And then the system automatically takes this declaration of what should happen and figures out how to make it true. And this allows you to create reliable, highly scalable, highly efficient pipelines just by writing a few lines of SQL. And then, of course, data pipelines are one small part of it. And so you can use Databricks workflows to automatically orchestrate your Delta pipelines, your BI queries, your reports, your model training, and your model serving. And this is all built on a foundation of reliability, performance, and governance with Delta, Spark structured streaming, and Photon. And we've brought to this Unity catalog, which I'll talk about in a little bit, that allows governance. And the nice thing about the Lakehouse is it can read data from any data source. And these common tools can then be used for a wide variety of use cases, from traditional analytics and BI to AI and ML, to even things like real-time streaming or securely sharing data outside of your organization. Diving into a couple of these, Delta Live Tables has been exploding in growth. We GA'd just a couple of months ago, about 12 months ago, and the growth has been over 177%. We now have 54% of customers that have some real-time. Real-time used to be something niche that only people with really big budgets and really low latency requirements were doing. But now that it's been democratized, anybody who has data that's constantly arriving can have the power of real-time. And then Databricks Workflows has been around for a little bit longer, but its usage continues to grow. We run over 100 million weekly jobs, and we process over 2 exabytes of data every single day. And it's not just Databricks. One of the key tenets of the Lakehouse is that it's open. And this means that the Lakehouse inside of Databricks works with a wide variety of partners, everything from data integration to orchestration to business intelligence. Now, when you go back to my example at the beginning, it was actually pretty easy for an AI to talk about JavaScript because there is information about JavaScript all over the internet for it to read and learn and understand. But in your business, what's going to set you apart is an AI that is trained specifically on your data. That's going to be your competitive advantage. And that's why we have now expanded the Databricks platform to be optimized for Gen AI and creating LLMs. And this happens at all steps of your journey. We have the ability to curate data sets using kind of our feature store, which allows you to understand how your models and features are changing over time, as well as native capabilities for vector search. Vector search allows the AI in real time to retrieve extra information about the thing that it's processing, but it does this in a much more intelligent way than just doing traditional full text search. It actually uses embeddings generated by the AI to understand the meaning of the content that it's looking up. And that's pretty powerful. So things like synonyms will just automatically work. We have all of the tools to curate models and to build your own, including a set of curated models that's already available, and then automatic training for and fine-tuning for LLMs. And then finally, when you're ready to go to production, we have all of the pieces for that as well. We have the MLflow AI Gateway, which records how your models are performing over time. And we have optimized model serving built on our serverless technology. So you don't have to worry about where you're going to get the GPUs from or how you configure them. You just deploy your model, and we figure out all of the capacity and other problems for you. And another kind of key part that you probably heard about in the news is our recent acquisition of Mosaic ML. And we're pretty excited about using this, not only to help our customers, but also inside of our own platform. One thing we like to say is that AI for data engineering is just as important as data engineering for AI. And we're making this true through a new technology called Lakehouse IQ. Let me show you a quick demo of what this looks like. So you can see here, we're just asking a question in normal English of our platform, and it's able to generate a SQL query because it knows what data exists inside of the Lakehouse. It understands SQL. It can write that query, and you can execute it. So what you can see is the foundation of Lakehouse IQ is all of the data that's already inside of your Lakehouse. Unity Catalog understands all of the different data and how it's governed. It's read all of our documentation. It understands all of the dashboards that exist. It can scan all of your notebooks and understand their content. And then it can use this to automatically generate queries based on just plain text, to do smarter search, to help you with administration, and even to build custom applications. Now, Collecting all of this data might sound pretty scary because a data leak can sink any business. And that's why we've created Databricks Unity Catalog. This is unified governance for both data and AI. It not only governs your tables and files, but it also governs things like models, notebooks, and dashboards. And this gives you one kind of single pane of glass where you can understand how data is governed throughout your application. There's a simple permission model that looks just like a traditional data warehouse, but expanded to all of these new different data types. And we have AI-powered monitoring and observability. And another really cool thing about Unity Catalog is, again, because the foundation of the Lakehouse is being open, we have the first truly open data sharing protocol inside of Delta Sharing. So the data inside of Unity Catalog isn't locked in, but it is securely accessible to only the people you trust with it. So going back to how we started, let's look at how we're solving those 5 C's. We make it easy to ensure that your data is correct with automatic bookkeeping through things like ML flow tracking, DLT's automatic operations, which means that you don't have to write Spark programs. Instead, you just write SQL queries and we figure out how to execute them correctly. And DLT expectations, which allow you to talk about what is expected of your data and what is abnormal. And the system can automatically measure it and have tunable policies for how to deal with unexpected data that might arrive. It's current because real-time is built into Delta and built into our system. And the nicest thing about the way we think about real-time is it's actually tunable based on your cost and latency trade-off. You can take an application from running once a week to once an hour to once a minute without doing any code changes. The data is complete because you're inside of one single lakehouse rather than a whole bunch of disparate siloed systems. It's all controlled and governed by Unity Catalog, and it's cost effective because we have record-breaking price performance. And if you don't believe me, I suggest you check out this report that was done by Nucleus, one of our partners, that shows that we lower cost and enable faster innovation for data-centric AI. And what they saw is that when you spend $1 on Databricks, you get almost $5 back in return on investment. You don't have to believe me because we have a whole bunch of case studies where we've talked about it. DuPont is aggregating data from across all of their different technologies and finding that the Lakehouse has enabled them to have the best cost performance. Edmunds is taking a data-centric approach to reduce bias and increase efficiency across their entire product and building industry-leading models and AI agents. And finally, even in the tech community, Replit is a company who's making it possible for LLMs to understand how to code. They believe that Databricks is a key part of the modern LLM stack. And so with that, I'll pass it back to Matt. Thank you very much.
Excellent. Thank you, Michael. So now that Michael has given us an overview of the landscape and hopefully a great appreciation for the value that data engineering brings to every single AI project, myself and my colleague, Ori Zohar, are going to talk about what it means to engineer data for AI, including some of the best practices and architectures we've been building for the last decade. And we're going to be taking a double click into data engineering on Databricks. So Michael just gave a fantastic overview of why Databricks is a great platform for both unifying all your data in AI and democratizing it for the right people in your organization. But as you know, this starts with data engineering. So we're going to double click into what it looks like to do data engineering on the Databricks Lakehouse platform. Again, kind of keeping that end goal in mind of building for AI. So Michael talked about the rise of generative AI in his keynote, and it's been so rapid, in fact, that many of you may feel like your organization's approach to implementing it feels something like this, right? We've got a bunch of data, and we're going to use it to create some really powerful AI models, and the stuff in the middle is kind of a black box that the engineers will figure out. The problem, of course, is that the black box is not so simple. The good news is that the mission of Databricks is to make it simple. So let me show you what I mean. The best architecture for data engineering is a Lakehouse architecture. With a unified framework for both data and AI, you can leverage a common storage, governance, and processing layer across all your data and AI. And built as a Lakehouse from the beginning, Databricks leverages Spark structured streaming and tools like Databricks workflows and Delta Live Tables pipelines to help you build, run, and orchestrate world-class ETL pipelines in a modern way. So with the Databricks Lakehouse platform, data engineers have access to an end-to-end data engineering solution for ingesting, transforming, and orchestrating data at scale. Now, we can't talk about data engineering on the Lakehouse without first talking about streaming. And between Spark and Delta Lake, we've been building on the whole idea of streaming as a default architecture for years, for every use case. Bear with me. Now, traditionally, data processing was done in batches, where data was collected and processed at scheduled intervals. This approach is becoming increasingly antiquated in the age of big data, where data volumes, velocity, and variety continue to grow exponentially. With 90% of the world's data generated in the last 2 years alone, the batch processing framework struggles to keep pace. Streaming architectures, on the other hand, enable data teams to process data incrementally as it arrives, eliminating the need to wait for a large batch of data to accumulate. When you're operating at terabyte and petabyte scales, allowing data to accumulate is impractical and costly. Now, the world is increasingly reliant on real-time data, and data freshness can be a significant competitive advantage. But the fresher you want your data, the more expensive it typically becomes. We talk to a lot of customers who express a desire for their pipelines to be as real-time as possible. When we dig into their specific use case, it turns out they'd be really happy to reduce their pipeline runs from 6 hours to, say, 10 or 15 minutes. Other customers really do need latency that you can only measure in seconds or milliseconds. And you can see some examples of desired latency for different types of use cases here, right? From true real-time use cases on the left, like high-frequency trading, down to more periodic processing jobs like inventory alerting or consumer surveys on the right. But this traditional view of categorizing use cases into batch versus streaming really is outdated. Instead, with Spark and the Lakehouse, we can and should view every workload through the lens of streaming architecture. Data streaming does not always mean always-on, expensive, continuous data processing. Streaming is essentially just incrementalization. You can choose when to permit that incremental processing, whether always on or triggered at specific intervals. The Spark streaming framework, and the Databricks Lakehouse by extension, allows you to set this latency versus cost slider to the optimal position for each workload. So while streaming, of course, makes sense for ultra-fresh data, it's also applicable to data traditionally processed in batches. Then, if your data needs evolve down the road, you've implemented a future-proof architecture that permits you to simply reposition the dial. Spark structured streaming, and again, Databricks by extension, also takes care of the bookkeeping, fault tolerance, and stateful operations instead of you having to manually track what data is new, what you should process, and what you shouldn't. For all these reasons, we must get out of the mindset of reserving streaming for complex real-time use cases. Instead, we should think of streaming as optimizing for right-time processing. Now, we do low latency real-time use cases incredibly well, and these are rapidly increasing among most of our customers. Real-time data is constantly generated by every individual, machine, and organization, from transactions in operational systems to customer interactions on the web and IoT data. Real-time data is everywhere. All this real-time data creates new opportunities to build real-time applications for things like detecting fraud, providing personalized offers, dynamically adjusting pricing, and much more. Data streaming is foundational to unlocking this new world of use cases around real-time analytics, real-time AI and ML, and real-time applications that in turn enable increased agility, better decision-making, and improved customer experiences. And many of our customers have realized this and completely standardized on real-time streaming architectures, and they've seen fantastic success. So customers like Walgreens are operationalizing real-time analytics on Databricks, enabling pharmacists to provide personalized recommendations and advice to patients in real time. Customers like AT&T are operationalizing real-time ML on Databricks to detect fraud in real time, preventing illegal activity and identity theft in a realm where every second counts. Customers like Edmunds are building real-time applications with stateful low-latency processing on Databricks that drives more accurate and timely marketing offers to their customers. One customer that has done this really well for all three of those use cases, real-time analytics, real-time ML, and real-time applications, is Vizio. And here's a really great reference architecture that they put together in a blog they wrote that showcases the power of the lakehouse paradigm for streaming data pipelines that enable real-time use cases. With Databricks, Visio says, we now have an architecture that unifies BI, AI, and streaming with linear scaling of costs, full observability, automated state management. It scales well, and it sets us up for success for our future plans. Now, we recently showed off a real-time analytics demo at our Data and AI World Tour in London, which I wanted to showcase because it's so cool. And in this instance, we had a driving simulator streaming data into S3, autoloader incrementally ingesting this data into queryable delta tables, with a Databricks Dolly model describing journey statistics in simple English, and then real-time dashboards plotting driver stats within seconds of being generated. As our friend Hugo says here, what a great example of what the Databricks Lakehouse is capable of. Now, BI and analytics, of course, is one thing, but today we're focusing more on AI and ML. And there are a number of customers who are architecting incredible solutions for real-time AI use cases today. A couple of my favorites are these two sessions from Data and AI Summit. So Providence Health is using real-time AI to accurately predict bottlenecks in hospital throughput and improve patient experiences. Really cool use case. JetBlue built the world's first AI and ML operating system orchestrating a digital twin for efficient and safe operations. If you're interested in learning more, please do watch these sessions. They're available on demand if you just search for them. The power of these solutions is astounding, and they walk through exactly how they built and operate them for real-time AI on Databricks. Streaming just has incredible applicability to AI workloads. But to get to real-time AI, right, you first need to build, run, and operate reliable data pipelines, carrying data from their sources to their final destinations with necessary cleaning, transformations, and aggregations in between. The best way to build data pipelines on the Lakehouse is through medallion architecture. A medallion architecture aims to progressively improve the structure and quality of data as it flows through each layer of the architecture, from bronze to silver to gold tables. To support ETL within a Lakehouse medallion architecture, you need to consider how you will handle the green icons at the top here. Things like deployment and operations. More on this in a bit. For now, let's start with ingestion, getting data into your Lakehouse. The bronze layer is where we land all this data from external source systems. Now, the bronze layer contains unvalidated data. Data ingested in the bronze layer typically maintains the raw state of the data source. It's appended incrementally and grows over time. And it can be any combination of streaming and batch transactions. And between native ingestion capabilities and our broad partner ecosystem, you can ingest from nearly any source you need. You know, a data platform is only as valuable as the data in it. Ingestion, therefore, should be simple, scalable, and cost-effective across all of your enterprise data sources. Between pre-existing native ingestion capabilities like autoloader for cloud files, or the connectors that we have for message buses like Kafka, Kinesis, and others, our recent acquisition of Archeon and the broad network of partners we integrate with, anyone from data engineers to analysts has access to easily ingest the data they need from hundreds of sources with minimal code. Although we've always supported coding approaches for those who want to do so, the Add Data UI makes it even easier to select data sources to ingest from. So users can simply click on the data source they want to ingest from, whether native to Databricks or supported by a partner like Fivetran shown here, and follow the UI flow or notebook instructions to finish data ingestion step by step. There are many dimensions to ingestion, but Databricks makes it simple. So across hundreds of sources, Databricks supports all widely used formats: Parquet, Delta Lake, text, binary, audio, video, geospatial, and so on. And this is huge for AI, right? So training data sets can include all kinds of data, including different types of unstructured data. So that's why it makes the most sense to use a lakehouse that can handle those unstructured data that are best for AI in the same place as your BI data sets. Only the synergies afforded by a lakehouse architecture can do this with unified governance and great price performance. It's just not possible using disparate systems. Another great thing about Databricks is the ability to ingest data via your tool of choice, no matter what type of data professional you might be. So data engineers can code ingestion into any notebook, or anyone using DLT can simply declare ingestion through streaming tables in a couple lines of code. Or analysts and lower code personas can ingest directly into Databricks SQL or via that add data UI I just showed. I've mentioned autoloader a couple times. Our autoloader functionality allows for instant incremental ingestion of files as they land in cloud storage. And then our streaming tables in DLT or Databricks SQL leverage that functionality for incrementally bringing data into pipelines or directly into a data warehousing environment. And this is great for use cases like change data capture, which many customers, like Block, for example, use for things like real-time model training. One of our customers at Labelbox, which is an AI and ML training data platform, says that he loves doing ingestion within DLT because it makes it extremely easy to read files within the context of a declarative data pipeline, which allowed them to set up their first ever streaming pipeline in under an hour. So here are a few quotes from some other customers who are ingesting a lot of data and have some very low latency requirements at the same time. So Akamai is a leading cloud security provider that processes about 30% of the internet's traffic. Their web security analytics tool is taking in about 10 gigabytes of security event data every second and needs to make threat information available to its end users within a matter of seconds from an event. Our friend Tomer at Akamai says that they were only able to hit their performance requirements with Databricks. Only Databricks gave them the combination of throughput, latency, and cost that would fit their SLAs in the security business. And then I have to shout out the Texas Rangers, who are my favorite baseball team, and as of the time of this recording, are in the World Series, just 2 years after being one of the worst teams in baseball. And their use of data analytics and AI is absolutely responsible in part for this impressive turnaround. After all, you can't make good decisions without reliable data. The Rangers are fueling their impressive run with a lakehouse that can ingest 4 times the amount of data as their previous cloud data warehouse at 7 times greater velocity for the same cost. And then AT&T, who I mentioned earlier, they're a very advanced Databricks customer, and they're ingesting and processing an astounding volume of data in real time. VP Kate Hopkins says the Databricks Lakehouse platform helps them ingest structured and unstructured data in real time to ultimately send downstream for reliable real-time ML models across a variety of use cases. So once you've figured out your bronze layer, the next step, of course, is data transformation. This is where you start thinking about your silver zone for validating and enriching data. So while the bronze layer contains the entire data history in a nearly raw state, the silver layer represents a filtered, cleaned, matched, merged, conformed, and augmented version of our data that can be trusted for downstream modeling. And while we believe strongly in the Lakehouse vision driven by bronze, silver, gold tables, simply implementing a silver layer efficiently will immediately unlock many of the potential benefits of the Lakehouse. Then that gold zone. So finally, data residing in the gold layer is usually highly refined and aggregated. Gold tables typically represent data that has been transformed into knowledge rather than just information. This is where you'll find the final data that will be used by analysts and end customers. As such, the final layer of data transformations and data quality rules are applied here. Okay, so you've got your medallion architecture defined, and this is all you want to have to think about, right? Data comes in, data is refined, data is made available for downstream use cases. But as you know, the reality is not so simple. It usually looks something closer to this. And this is before you even start thinking about things like deployment infrastructure or version control. Things like data discovery and governance and quality checks. And what about operational bookkeeping like backfill handling and dependency management, checkpointing and retries in the event of a failure, partition computations, and so on? As it turns out, the job of a data engineer tends to encompass a whole lot more than just the data itself. So there's never going to be a perfect, omniscient, 100% automated, singular solution for all your ETL needs, right? There's always going to be complex, hairy data problems to solve, and edge cases to architect for. But I bet there are a lot of tasks for a lot of your pipelines or core components of your pipelines that you would love to automate. And this is exactly how Delta Live Tables, or DLT, came about. Again, you just heard from Michael Armbrust, one of the world's leading experts in data engineering and the creator of Spark Structured Streaming and Delta Lake. And Michael has led the creation of DLT to solve for a lot of these common operational challenges and abstract away as much of the common friction behind ETL pipelining as possible. So DLT pipelines are an opinionated view of ETL pipeline best practices that our customers tell us regularly encourage and almost enforce good design. So, for the Spark experts who love to code and build, Databricks will always be your lakehouse. For niche use cases, Databricks will always be your lakehouse. For maybe 80% of the data pipelines your organization is building, and your mileage may vary, but especially for practitioners who want to be spending less time on operational overhead, DLT is the easiest, best way to build pipelines on the lakehouse. DLT is the first ETL framework that uses a simple declarative approach to building reliable data pipelines and automatically managing your infrastructure at scale, so data teams can spend less time on tooling and focus on getting value from data. With DLT, engineers are able to treat their data as code and apply modern software engineering best practices like testing, error handling, monitoring, and documentation to deploy reliable data pipelines at scale. Most importantly, DLT gives you confidence in your data. One unified API for batch and streaming processing, plus data quality features like expectations, testing, and monitoring, make it easy to ensure your data scientists and ML engineers are getting reliable data for reliable models. Now, although of course we support batch processing, I talked earlier about streaming architectures being our default and building everything around this idea of incremental processing, whether it's always on or triggered. And to make this happen, incremental pipelines require two ingredients: incremental ingestion and incremental transformation. Accordingly, DLT pipelines are built from two fundamental building blocks: streaming tables and materialized views. Streaming tables and materialized views are really powerful objects that you can use across the lakehouse, not just in DLT, but also natively in Databricks SQL, or even in dbt with Databricks SQL. So data engineers, analytics engineers, and so on can build low latency streaming ETL pipelines using their tool of choice. But let me unpack these two concepts a bit, starting with streaming tables. A streaming table is a special type of table for ingesting and processing streaming data on the lakehouse. These used to be called streaming live tables in DLT, but we're actually deprecating that terminology, so they're just streaming tables moving forward. But you can use streaming tables to enable all your data practitioners, so not just data streaming experts, but all your data practitioners with a simple SQL syntax to ingest data continuously arriving in cloud storage and message queues. You can use them to more efficiently process high volumes of data incrementally versus in batches. And then finally, you can use them to support real-time analytics, machine learning, and operational use cases requiring streaming data. Again, this is the first kind of primitive that Delta Live Tables pipelines are built on. The second is materialized views. And a materialized view is a unique way to perform complex transformations for ETL and accelerate end-user queries. What are the benefits of materialized views? Well, first, they allow you to perform complex transformations in a very simple declarative way. You can define them on top of any query as well, which is why they're ideal for ETL. Second, they improve data freshness by avoiding the need to rebuild a full view when new data arrives, lowering overall compute time. And then finally, because this data is pre-computed, your end users get faster dashboards. So this is a lot of conceptual information. How do you actually use these concepts? The answer is actually quite simple. With a few exceptions, most use cases will use streaming tables for ingestion and materialized views for transformation. With streaming tables, you have a fast way to get raw data into your lakehouse where you can store it cheaply for as long as you need. Once data is in your bronze layer, you can apply materialized views on top to define what your silver and gold layers should look like, and let DLT automatically handle that complexity behind joins, aggregations, updates, deletes. That's the magic of declarative syntax, right? All you have to do is say what you want the output to look like. In this case, your silver and gold layers, and DLT figures out how to make it happen efficiently. So this is enough theoretical talk. Let's see what this actually looks like in the Databricks UI. In this example, we're building a data pipeline for a financial institution, okay? We're going to start in the workspace part of the UI where you can put your code together in a notebook. And first, we're going to simply declare a bronze landing zone for 2 different data sets. To create these 2 streaming tables, all you need is 6 total lines of code, 3 for each table. After we've established our bronze layer, next, this silver layer is used to join tables and apply expectations for data quality. Expectations allow you to guarantee that data arriving in tables meets data quality standards that you've set. They also provide insights into data quality for each pipeline update. By the way, Michael talked about Lakehouse IQ and Databricks Assistant a few minutes ago, and this is completely embedded in DLT. So you can automatically generate documentation and auto-comment your code. It can find errors and even fix your code for you. It can generate net new code to accomplish a task. It can tighten up and prettify messy code that you've created. And Frank's going to demo some of that in his section. Then finally, we've got our gold layer, right? So the gold layer curates data for downstream systems. And here's where we for sure use a materialized view where the results have been pre-computed. So now we've declared what our DLT pipeline should look like. So we're going to navigate over to the DLT pipeline view in the UI, which is where we get a visual representation of those few lines of SQL code we just typed out, including all the tables and their dependencies. Then when you start running this pipeline, you're able to easily monitor the results, the status of the run, latency metrics, data quality summaries. Remember when we added expectations into the code for our silver tables? Here, we can see the results of applying those particular constraints, including bad data we told DLT to log, drop, or quarantine. So you can see why creating pipelines in DLT is not only a tremendous time saver for customers, but also democratizes access to this data and encourages collaboration. Our goal is to remove any technical barriers that data teams might have to working with business critical data, something the whole Lakehouse is set up to support, from DLT pipelines to Delta sharing, Unity catalog, and beyond. Now, we mentioned JetBlue's real-time AI talk earlier, and they are a great example of a customer that has seen tremendous advancements in its data team's ability to easily implement complex architectures with both data engineers and data scientists able to easily collaborate together in Delta Live tables to get the data they need to build good models. The data team at Honeywell has found the same thing to be true. DLT has empowered dozens of practitioners to collaborate on procuring and using the data they need. Reliable data like this is the key to good AI, and Databricks is built to help you deliver it. So now my colleague Ori is going to talk about orchestrating pipelines and more on the Lakehouse.
Thanks, Matt. Before I dive into Databricks workflows, I want to talk a little bit about how critical data orchestration is. So looking at this Gartner quote, we can see that data pipelines are growing in size, volume, and complexity. And that's not a big surprise if you are building these pipelines. You're seeing more kind of data assets across the organization being used, whether it's in batch or, as Matt just said, streaming, which is becoming more and more of a use case. The pipelines themselves are more complex, multi-stage, and have more and more dependencies. And finally, they are used in more and more use cases, whether it's ETL, analytics, machine learning, or real-time applications. This means that orchestrating all these pipelines is becoming much more of a critical thing. Now, we know that the Databricks Lakehouse is there to unify all the workloads around data and AI in one place. And therefore, Databricks Workflows, which is the integral orchestration tool, is there to unify orchestration across all these workloads. The 3 key features that we are excited about and find that customers really like about Databricks Workflows is that it offers simple authoring for any practitioner. actionable insights through a deep integration with the platform that offers a lot of observability and deep monitoring. And finally, proven reliability, just by being a managed service and having the scale and expertise of Databricks behind it. So let's dive in a little bit into each one of those specific areas. Let's start with simple authoring for all data practitioners. So Databricks Workflows offers a really easy way to visualize any workflow or any pipeline you're building. And with just a few clicks, you can define different steps in that pipeline, how they depend on each other, schedule that pipeline, and so on. The UI offers practitioners who are not data engineers the same ability to manage and monitor their own pipelines. But if you prefer, you always have the ability to stay in your IDE, use the API, and so forth. So really, Databricks Workflows meets you where you are and helps you, whatever your job title is, to create and manage your workflows the way you need to. Now, Wood Mackenzie is a Databricks customer that is in the energy field. They process around 12 billion data points a week. And by switching to Databricks Workflows, they found they are able to use a lot of DevOps capabilities and practices. And they found something interesting, that as they standardized on one workflow, it encouraged more collaboration, removed silos in the organization, and really allowed them to speak the same language. Now, let's talk about observability. Databricks Workflows gives you a great way to visualize how all your pipelines across the organizations are running. You can easily filter when you have multiple pipelines and explore what everything is doing, but you can also deep dive and double click on each workflow and see what task exactly is running, how long they took, if a specific one failed. So it's very easy to troubleshoot and see where failures happen and then mitigate those failures. This is only available because Databricks Workflows is an integral part of the Lakehouse. So external orchestrators, which a lot of people use, don't have that ability. They don't understand the environment where your workload is running, which is critical when you want to offer deep monitoring and observability capabilities, which is another great thing about Databricks Workflows. Ahold Delhaize is a big retailer in Europe, and they actually switched from Azure Data Factory to Databricks Workflows. They run about 1,000 ingest jobs at all times, and they found, on top of finding around 50% cost reduction, they found those observability capabilities to be essential. So as you can see in this quote by their tech lead of platform engineering, Databricks Workflows allows us to clearly see how every job is run. We have all the information right in front of us, which is not something they could do with their previous solution, which was Azure Data Factory. Finally, another thing that customers really appreciate about Databricks Workflows is the proven reliability. So Databricks Workflows is trusted by thousands of customers that are running millions of production-ready workloads every day. This is a managed service, fully managed, so you don't need to spin up any VMs or deal with updates to versions or licensing. It's included in the Lakehouse that you already are using. It also offers really high uptime of about 99.95%. And so you don't need to maintain or worry about downtime. And this is especially beneficial as we're moving into serverless data processing. We're going to touch on that a little bit later. But with serverless, you get even more reliability and much more. And using the scale of Databricks and our expertise in running these workloads, you get even higher reliability at massive scale and removing additional maintenance burdens. But we're going to talk about that in a minute. Now, Yipit Data is a company that's been using Databricks for a while. And due to that manageability advantage of having Workflows as already a managed service that's included in the Lakehouse, they're actually very happy to move away from Airflow Apache Airflow that required a custom setup in their environment. And in this quote, you can actually see Hilevi, their engineering manager, speaking to the fact that if Databricks Workflows was available back when they made those technical decisions in 2018, they would not have even attempted to build their own setup with Airflow. And this is a sentiment we hear again and again from customers. Rather than having a lot of tools, different tools they have to maintain and manage, just removing those and using one thing that's all-inclusive, such as the Databricks Lakehouse. Now, let's double-click a little bit and understand a little bit better what are the building blocks of Databricks Workflows. So a unit of orchestration we call, in workflows, is called a job. A job is usually made of one or more tasks, and you can think of those as steps in a pipeline. Now, each step can be implemented in a variety of ways, and Databricks Workflows supports many kinds of tasks, whether it's notebooks, Python scripts, dbt projects, and you can even see in this list DLT pipelines that can also be orchestrated as part of a bigger pipeline or just in itself. The second thing when you're orchestrating, you need to think about, aside from the specific tasks, is the control flow, or usually these are defined in DAGs, directional acyclic graphs, and basically define the dependencies or the way those steps flow. It could be sequential, parallel. We also offer conditional, so whether a parameter is set in a certain way or a runtime condition happens, this branch is part of the control flow, or the other branch. Databricks Workflows also offers a modular execution, meaning running a job as a task, which lets you really break down complicated workflows so it's easier to manage, to test, and to repeat the same kind of tasks again and again in different workflows. Finally, when we think about triggering, so when does a pipeline actually run, Databricks Workflows offers an array of different options, whether it's manual, scheduled, using an API, but also just-in-time running, whether it's when a file arrives and you want the pipeline to be triggered, but very soon also Delta table changes that will trigger pipelines. Finally, for streaming scenarios, Databricks Workflows also offers the ability to run continuously and always be available for incoming data. Now, let's talk a little bit about execution and compute of these pipelines. So if you're just doing development and exploratory work, you can use interactive clusters. These are usually not really production ready, but they're easy to set up and usually a good way to get started. Once you're ready to productize, we recommend you move on to job clusters, first and foremost because they offer tremendous cost savings of approximately 50%, but it depends on what exactly you're doing. They also offer cluster sharing, but sometimes they can be a little slower to start up. The real exciting thing is where we're moving to, which is serverless workflows. With serverless workflows, the compute is completely managed by Databricks. So auto-scaling is better, cluster setup is faster, and you see a lot better out-of-the-box performance. We do a lot of optimizations behind the scenes, and which all contributes to a lower overall TCO for you. Now, for workflows specifically, again, serverless compute removes a lot of the burden of deciding which kind of cluster you want to run for your pipeline. Basically, you would give it a general guardrail. I want it to run as fast as possible, or alternatively, be cost optimized. And we will do everything in the background, all the magic that's needed coming from our expertise and our economies of scale to run something more cost effectively. And because we have a warm pool of clusters, we actually spin them up much faster, and also can kind of buffer between you and some failures that might happen at the cloud level. When it comes to DLT, another area where serverless is coming soon, you can see that because of dynamic optimization and scheduling that's happening in the background, you can see ingestion being sped up. And you can see that on the right-hand side, where DLT serverless even speeds up more than the already sped up DLT that offers today. Now, on top of these things that all contribute to better performance and pricing, there's additional features in the platform that give you the best price and performance, starting with Photon. Photon is the highly optimized query engine that is used for any kind of query, whether it's a data warehousing kind of query, but also ETL, ingestion, streaming, data science, and really gives you the best price performance in the market. On top of that, if you're using Delta Live tables, as Matt just showed, you get this enhanced autoscaling that is even available today, and it's going to be even improved with serverless, where DLT, because it knows your pipeline, can do a lot of much better autoscaling beforehand. When it knows something is peaking in an earlier part of the pipeline, it can spin up more instances in a later part and really mitigate a lot of those kind of volatility we sometimes see with these kind of workloads. And finally, built on Delta Lake, with all its performance features, the Lakehouse really offers you a lot more optimizations, even at the storage level. So I just want to leave you with this last customer story. InMobi is a customer that they personalize ads, and they process around 20 terabytes per hour of data. So they're very price performance sensitive. And they chose the Lakehouse because of all these features that I just mentioned, and they've seen an overall 24% cost reduction for ETL. So with that, I want to thank you for joining me and Matt to discover the capabilities of ingestion, transformation, orchestration on the Lakehouse. And back to you, Matt.
Fantastic. Thank you so much, Ori. There really is a lot that data teams have to stay on top of. And I think I've personally gotten a much deeper understanding from researching for this event how complex these problems really can be. Sometimes it's most helpful to hear from real customers who have put some of these best practices into production in the real world. And for that, I'd love to welcome T-Mobile's Vikas Ranjan to discuss how his team has thought about architecting their platform for AI.
Hello, everyone. My name is Vikas Ranjan. I'm a senior manager of data analytics team in the Network Strategy and Evolution department at T-Mobile USA. I'm very excited to talk to you guys today about the exciting world of data engineering for AI. Before I go and talk about all the exciting stuff, I want to talk a little bit about what my team does here at T-Mobile. My team in T-Mobile is responsible for building end-to-end data engineering, data analytics, and AI-based solutions for a massive scale modern data estate. Well, we are so blessed to be living in the era of evolution and innovation. If you want to go and buy a new book at Amazon and you have browsed some books in the past, the first thing Amazon does is provide you some recommendations. Hey, Vikas, this is probably the right books you want to buy based on what you browsed a week back. Time is always a challenge for all of us in this world. We are all very busy. We want to go from a place A to place B, and we always want to reach there as fast as we can. And here comes the power of AI in Google Maps. Google Maps is doing this real-time data collection and providing a recommendation of maybe there is another way to reach there faster. We are all traveling and leveraging Google Maps when we are driving a car. And here came the power of AI by Tesla by building self-driving cars. And last but not the least, you want to send an email to your executive and you are struggling and scared. How do I want to type an email? What should I write? What should I not write? And here comes the power of large language models, or the power of copilots of the word, which is actually helping you type a really awesome email to your executives. In a nutshell, we are living in the world where AI is all around us, wherever we go and whatever we do. How does this AI really happens? When we look at a traditional AI and ML development lifecycle, it always starts like with any other project, is defining your use case. Are we trying to send a new campaign to our customers and potentially generate a new revenue stream for our business? Or are we trying to automate some processes to reduce our time to market and hence reduce our cost? Or we are trying to do something to avoid our cost? Once you have defined a key use case, the next thing which is extremely important in any AI development lifecycle is the data. You need to procure multiple different data sets. You need to prepare and process and curate and cleanse this data set. And then you go towards doing all your cool AI model development, model training, all the way to deploying your model and doing ML ops once your models are running in production. In my experience working in the space of data for almost 20 years now, and in the AI and ML space for the last few years now, in many cases, we have seen an actual AI project has taken almost 60 to 70% of our development time in actually building a complex data engineering pipeline. And as per the pioneer and the father of a modern machine learning AI, Dr. Andrew Ng, you need good data, not big data, to drive good decisions. Well, what's make this data engineering so daunting, so challenging, so scary? In our experience, in my experience working at T-Mobile, I have been dealing with, my team has been dealing with some highly complex network logs. Many of those comes in very specific telco proprietary formats. Some of those data sets comes in tens of millions of files per day. Some of those things are essentially coming with a different diverse size file per each feed. Volume is a big challenge for many organizations and teams, and for us as our business continues to grow. Our customers continue to leverage more and more assets on our network. That in turn generates lots and lots of data. And today we are processing almost a north of 1 petabyte of complex network data per day with trillions and trillions of records. Gone are the days when we used to do analytics for what happened yesterday. Our business today wants to identify an issue when it happened. We are talking about if an outage happened on the network, what caused the issue? What caused the outage? When it happened, not after it happened. We want to leverage machine learning and AI to build outage prediction models in real time to provide insights to the business now. To do all of those things, when you're dealing with the highly complex, highly volume, real-time data, your models are only going to be reliable, are only going to deliver value if your data is clean, if your data is pristine, if your data is trustworthy. Hence, data quality, data reliability, it brings its own set of challenges and opportunities for any data engineering teams. We are living in a world where technology landscape is changing every single day. Until 3-4 years back, the large language models and Gen AIs of the world were more of academia. Today, we as a data engineering teams, as a business teams, are talking about how do we leverage some of those things into our day-to-day work and our business use cases and processes. And for that, you need to make sure you are having the people with the right skills in organization. And all of these things are really, really important and work really well if you have a right governance to manage your data management lifecycle. This is sounding so scary. How do we actually make that happen at T-Mobile here? In our organization, like any other data-driven organization, we are leveraging 2 different design patterns. One is a streaming or an event-driven architecture where we are bringing some network events directly from our network systems and logs with a 5-minute latency into a Kafka bus, which has like billions of transactions per second. And the first thing is like always building a strong data lake or a lakehouse IQ implementation, in this case, a Mendelian architecture, by bringing in all the data into your bronze layer and leveraging some of the really cool features of Databricks like autoloader for ingestion of data and structure streaming for processing, curating, and ingesting this data into a near real time. In our case, typically for many of these analytics, we do that within 15 minutes of when the data actually happened on the network to the time we present this data to our engineers, to our business user, to our machine learning scientist within less than an hour. At the same time, we are dealing with a high volume of file-based streaming architecture. In this case, we are getting millions of files from traditional telco data sets like call detail records, which is basically capturing your voice calls, capturing your data experience, your coverage experience, as well as other aspects of network. And in this case, all the files are pushed by mediation systems into a landing layer or a bronze layer, and we are leveraging functions of Databricks here to basically parse the files, curate the files, process the files, and present the data to, again, our end users, either through Databricks serverless SQL or through Databricks notebooks, as well as machine learning, Azure ML, as well as data machine learning for ML development. And in order for us to kind of leverage and build all those pipelines, we are heavily leveraging log analytics for logging and telemetry and health of our pipelines, as well as our infrastructure today. To manage all of those tens of thousands of data sets, tables, columns, fields, permissions for users, we are leveraging Unity Catalog for both data and AI governance. What have we seen in terms of success so far? When we started our journey 3 years plus back, we were processing a very small amount of data, versus today, we are processing around 200 terabytes of raw network logs, as well as 400 billion plus records by leveraging Databricks functions and features. Recently, we implemented a new project in our production pipelines where we saw 3x increase on developer productivity by leveraging some higher order SQL functions that helps us with the complex data structures and data transformations and filtrations than earlier when we had to build all of those UDS functions from scratch. We have seen a tremendous value with Delta Share by increasing collaboration with data scientists across the enterprise for AI and ML use cases without physically moving the data in our enterprise, by having our marketing teams, by having our finance teams, other business teams correlating and bringing the power of network data with the marketing data and the finance data and billing data without physical movement of data for all the new machine learning use cases we are developing across the enterprise today. And last but not the least, we have seen super awesome value from leveraging serverless SQL for exploration for end users, rather than them managing the infrastructure of Databricks, VMs, picking up type of different VMs. By bringing them a serverless SQL feature, we are essentially enable them to focus on business innovation than managing the infrastructure. In the end, I would like to share some of the best practices that we have embraced, adopted, implemented into our data engineering processes, as well as our machine learning and AI processes on a daily basis, working on this space for quite a while now. The first and the foremost is when you are dealing with the 1 GB of data versus 100 terabyte of data versus a petabyte of data, the most important design principle is scalability. Build your solution for scalability. Leverage the features of Databricks like DLT, leverage auto scaling to make sure you're getting the best back for value for the buck by building those pipelines the right way in the beginning. Databricks provides some really, really awesome features that we have leveraged heavily into our data pipelines by leveraging Delta for our data lake, as well as using SQL functions, autoloader for our ingestion as well as serverless, as I mentioned earlier, for our power users and business users. When you have tens of hundreds of pipelines running, processing terabytes of data every day, automation and your deployments is the key. Make sure to leverage and build your CI/CD and deployments into your processes. As I mentioned earlier, data quality, data trustworthiness, data preciseness is extremely critical and important to deliver and build high quality data products with and without AI. So make sure that you are integrating data quality checks as a part of your data pipelines for proactive identification of issues rather than reactively monitoring the issues later. Logging, alerting, and monitoring is extremely important when you have a high velocity, highly moving data teams building data products to make sure you have built operational excellence across your different data product teams. Unity Catalog is a really, really awesome feature that we have leveraging heavily across for all our access controls for our users, for data sharing across our enterprise, as well as managing and our data assets. One thing we have heavily spent some time over the last year or two is what we call as building an internal knowledge base repository. That is extremely important when you have 5 or 10 different data product teams all working their own pods into their own scrums on building multiple different analytics solutions, data engineering solutions, AI solutions, to share what is the best practices of them. How do you build a highly scalable pipeline so that you can share that not just with your data engineers, but also with your data scientists, ML engineers, as well as your power users who are leveraging the power of the data wealth you are collecting in your ecosystem. And last but not the least, make sure to continue to invest in your team upskilling, whether it's large language model trainings to see how we can bring in some of the best practices of large language models into your data engineering using low code, no code, or some of the features Databricks has been bringing recently or talking about with the Lakehouse IQ, or doing workshops with both your partners as well as doing it internally. And as they say, you should always invest time by drinking your own wine and doing hackathon, hands-on hackathon, to look at the new features that are coming and how you can bring that into your day-to-day pipelines for both engineering as well as for analytics, so that you're always building the best solutions possible. That concludes my talk for today. Thank you so much for having me. If you have any questions, feel free to reach out to me via my LinkedIn handle. Thank you.
Amazing. Thank you so much, Ficus. You and your team are doing incredible work with data and AI.